Hello there. I'm going to explain to you and show you how the package manager works. And what this is a script that lives in your drive as a kind of a service. And what it does is it allows you to make other projects. So if you think of it as being kind of a mother script that makes child scripts. And in the end, what you get is a toolchain for sharing these libraries, which we can write in AppScript. And it also, if you wish, you can use a test-driven development framework, or basically just have a bunch of tests. The motivation for doing this this package manager stems from how libraries currently work and criticisms I have of them, which I explain here. So the way I see the current libraries working in the AppScript, while there is a mechanism for it. There's a few problems with it, which one of them being not even the worst part, actually, but one of them being if you want to use these libraries with an add-on, they're not actually recommended by Google to do that. They say for performance reasons. But even if they were recommended, I still think we're sort of shooting ourselves in the foot with these libraries, because even though it's a library, it's difficult to discover, it's difficult to import. You find the project key, you import it that way. It's all kind of magical behind the scenes. You can't see the code. You're not sure how it will work with it. What's the interface for it? But on top of that, I think because they're hard to discover, they're hard to use, or whatever, the development of the libraries at the moment seem to be quite stagnant when you compare that to other stacks such as JavaScript or maybe Python or some other stacks that have a very wealth of library options available. Whereas in AppScript, I don't see that same diversity. And with current libraries, I've not seen any tests done with libraries, which is hard to, which means it's hard to be dependable for long term in terms of stability. But anyway, so the solution, what I think that how a library should work, and obviously I've come from a kind of a different background to app scripting. I actually originally came from Python, so I'm very strongly influenced from that particular language environment. But the solution so my background will obviously inform my solution, but I think they should be these libraries should be embedded within a project itself. I think that should just be downloaded into our own projects. We should be able to inspect them if we wish, for open source. We should use GitHub because GitHub is just where everyone is. Easy to find stuff on there. We can. The solution would mean we should be able to fork them, add issues for problems, communicate with the original developer without actually knowing who the original developer really is. And again, I think tests should be included with these libraries as well. Although, not having tests should still be an option. It's with the ideal solution. I think developers should have them, but the solution is not going to require or force developers into that sort of frame of mind. So the solution I'm thinking of here is the package manager. So how do I think this solves it? What the package manager does is, by being a mother child that makes other child projects, being a mother script that makes other child scripts, what it does is it adds a toolchain workflow in Python or another stack that would be similar to be using the command line to initiate projects or to bring in projects or in libraries from other sources. And in this case, what Package Manager does is it uses GitHub's API to download and bring into the current project that you're in on the actual the online editor itself. So you'll see the file on the left side, just like you would with any of your other files. So with the Package Manager, it lets you develop a library from scratch, publish it on GitHub. Others discover these libraries. They include them into their own projects. They include them the functional source code as well as any tests you write, and then after that, if another person wants to use it, they don't use a project, the lab script project. They actually go to GitHub as a source of truth. So any refinements or improvements on that library would happen on GitHub for the future. So if you're using it on an add-on, it's not like using a library currently. It's actually a file in your source code. So how does that work exactly? I'll try to explain with some code and some mental models to explain. So for the explanation, I'm going to assume we're writing an app called Sample App. We have a sample app that depends upon library A. We need to use library A as a dependency. It's a library someone else wrote. Library A itself has a dependency, library B. So this package manager is going to not only allow us to download library A, it will also download any dependencies it declares, including library B. And so these two libraries will be available in the apps, in the sample app, and they will be developed with test-driven development, which is an option for this package, but I want to show off all the cool features. All right, so what does it look like in terms of code? If you have you have just some function, your main function, what it does when you're programming with this framework, on top of this framework, basically, you have a global variable called PKG package, and that will. What that does is you get PKG and a namespace is added onto that global variable like this. That gives you library A and all of its features. And in this case, the library has one method called doSomething. And you call it and you get the result. Very easy, very simple library. This line here is just to emphasize that because library A depends upon library B, it also includes library B into your project. And so that will also exist in your project. This is what a library looks like. This is how you write a library. And again, because this is a toolchain solution, you don't have to write this every time. What the package manager does is it actually sets it up so that your project has this code available. It's kind of as a boilerplate, already written down for you from here to here, and this part. But then you're going to write the function package. So the library writer just writes the function package. It returns the object, which in this case has one method, and all it does is return an empty string. All right, so how does this work? Well, this is a self-invoking function. The invocation actually starts here. So this gets passed to the global variable here, and this whole function becomes this variable factory. And so after that, now we have the global. Because it passes this is the global context, and I can build upon the global context. I can make a global variable basically. And what this does is it adds PKG namespace if it's not already there, or if it is already there, it will just replace it with itself, so it doesn't do anything really. And then it builds upon a PKG namespace by adding a library A object. The object in this case is a function. You call the function, you get back an instance of the library, which when you call it returns the factory with the any arguments that you applied onto it. So you can just go back here. That means that you could pass something here. You can pass maybe some config or something else, and you have access to it in your library here because it applies the arguments onto it. All right, so that's what a library looks like, and this is what a unit test looks like. So if I'm doing some unit tests with my sample app, I've incorporated a library. I'm using a library called UTGS. Now that library is the unit testing for Google Apps scripts. That's the library that I've written. This is the library that enables some of these features in here that you see here. And again, like I said, this is actually optional. It's declared as a library, so you can actually, if you don't want to use test-driven development features or things, you can just not include the library, and you just won't have to bother with it. But tests are good. I think they're essential, and so what this does is you get an instance of this library, and I actually see a typo here. This here should be UTGS. I meant to you're passing this into here, which then you get there as UT. So since this is another self-invoking function, you might be wondering, why do I do a self-invoking function? The reason why I do it is because I like how I can name the kinds of tests that are going on here. Just my preference. You don't actually have to technically do that. But if you're following along anyway, so you still have this object that's just part of the library. You get to describe, and you can describe what you're doing. Your testing method do something. The method, it should return an empty string. And then so here is actually the body of the tests. You have package A, you get an instance of it. You call library A, do something, and then it asserts that they are equal. So if it's not equal, if the assertion fails, the log will indicate as well, and if the assertion passes, it will indicate as well. This is what UTGS does. And in the end, it returns the result, meaning true if all the tests pass. Like if I have more than one here, it would return true if all of them pass, false if not. And so that's how the unit testing would work under this framework. Okay, so now that we have some of the code in mind, how it looks to actually code it, I want to explain the mental models needed to actually work in this environment with this framework. So like I said before, the package manager itself is actually kind of a mother project. You include it into your drive just the once, and it acts as a kind of a service for other projects that you make. The toolchain is what allows us to kind of communicate with the different these different projects. So if I'm making a sample app, I'm making a new project from blank, a blank new project. I would go to the toolchain in PackageManager file. This represents a file within the project. And there's a function there called init_project. I would go there, I'll simply run it. And what it will do is it will make the child script here, and it will make a gist on GitHub, which will be here. These represent other libraries that exist already. So here's that unit testing for Google Apps Script library. This has a dependency of Context Manager, which is here. And here's the library A. This has a dependency which is declared here for library B. Again, these represent files that are in each of these libraries. And so the idea here is what this is displaying is that when I run this init project, it will then go to make a new project, and then it will incorporate UTGS into the project automatically. Then by looking at the setup file, it knows that it needs to include the context manager, which it does as well. Because I haven't yet, it's a blank new project, I have not set up library, the dependency declared under library A. I'll show you how that works. So I run init project. It makes this child project sample app, and it makes a gist with these files on there as well. Okay. Now, when it does that, we will have some files as indicated here. Okay. And so these files should be the same as there. These files are the library files. All right. So let's go run through it from the beginning. You have a project manager. You run this function. It makes a sample app. It makes the gist as well. Now the dev file, which is here. These are the same. Yeah, setup there, sent to there. And again, setup is blank at first because I haven't declared any libraries that I need for my app. Dev is not blank. By default, it includes the UTGS library. Now you can turn it off, right? But when this init project is run, because it's not blank, it declares it needs the unit testing Google Apps Script library. It automatically includes it. Not only that, it just includes that there, but it includes this one as well. It includes the unit tests as well. And the file name follows the convention of pkg dot. That way we don't run into name conflicts in our project file names. Okay. Another file that's included is the pkg dot _ toolchain, which is sort of, if you want to think of it like it's a kind of, if you have another operation, another toolchain operation, it shares the same name, just to remind us of that, how that works. So the next thing we're going to need to do, because our sample app we know needs to use library A, we need to say, let's use library A. How do we do? We have to modify the setup file. We modify the setup file to add it, and all it is define a, like a key, library A, and a gist ID for the value. Okay, so when I change that file on the project itself, what that means is that doesn't do anything, but I have to kind of invoke a function to tell the package manager to download it again. So this is where that toolchain file comes in, because you can open that file. It has two functions. One of them is called PackageManager push, and one PackageManager pull. So because I've updated the setup file, I'm going to push that information, the current project as it is, to GitHub. It's, so basically what that means is that this will become the new version of the value of the new library here will go to there. Then I pull it, which will then look there and download everything it needs into the project, which means that it will look at, when it does that pull, it will then see the setup has changed. Well, not changed, it sees that there's a new library declared in the setup file. and then we'll go to library A's location and include these files into there. So after I run that, I will end up with these libraries. I have library A and library B. And notice, because even though that the file library A has a main file called lib, that there's no name conflict here because of the name change in different names. Okay, and also it includes the unit tests. Now the way, just to quickly go over how this toolchain works, is what it does is that push and pull actually go back to the package manager, communicates back to the package manager mother script that has the functions of incorporating into files and reading and updating the gist as necessary. So that code actually still lives there. The code in here is actually very minimal, very lightweight. It doesn't add much to the project. And when you're ready to publish it, you could actually delete this file entirely, and it'll work fine. And so the next thing we want to do is, once we've got the project set up with the libraries we need, we can begin development. So we could go start writing our main function. So we make a new project file, PF or project file, and we start coding, we write our app, and when we're done, we can then push that to GitHub, which will be on a gist. So and obviously, because it's a gist, if you don't want to publish it, you can make it a secret gist as well. And basically, that's how it works. All right. Well, thanks for making it for that far. If you're still here with me, my next video will actually do the coding. But now that you've got the mental model, that will make a lot more sense. Thanks.